Hey guys, in this video we're going to present the paper titled Twitter Mood Predicts the Stock Market by Johan Bolin and others. The presenters are Xinian Zhao, Yishin Pan, Jean Lee and Ayush Ahuja. So the task of the current paper is to investigate whether data from Twitter correlates or can even predict changes in DJIA values. The DJIA stands for Dow Jones Industrial Average, which is a financial index capturing the trading activity in 30 large, publicly owned companies based in the US. For the dataset, they use around 9 million tweets from February to December 2008. The high-level algorithm they adopt is to extract sentiment, mood information from tweets on a particular day using standard off-the-shelf sentiment analysis techniques, and they employ linear and nonlinear models to study the correlation with the Dow. They divide their analysis into three phases as presented in the next few slides, and each phase builds upon the observations and conclusions from the previous phases. Finally, they're able to show correlation between information extracted from Twitter and the Dow movements. In the first phase, they perform some pre-processing and subject the tweets to two standard mood assessment tools, Opinion Finder and GPOMS, which stands for Google Profile of Mood States. While Opinion Finder outputs the overall positive versus negative mood from text, the GPOMS analysis results in a more fine-grained information in the form of 6 mood states, including calm, alert, sure, and happy. So the Opinion Finder results in the blue series shown on the top right, and GPOMS results in the 6 time series shown in the bottom right. Each day contributes 1 point to each time series. So how do they determine the Opinion Finder series? Basically, OF is based on a vocabulary of terms technically called a lexicon. For all the tweets on a particular day, they find the words that are marked as strong or weak in this vocabulary and then take a ratio of the two. For the GPOMs, they expand the original number of terms in the questionnaire from 72 to 964 by analyzing word co-occurrences. Then for each term in the tweet, they see if the term is present as part of an n-gram with the GPOM's terms and assign a score weighted by its co-occurrence weight. They do this for all the 6 moods. They first try to correlate these mood series against last socio-cultural events. The shown time series captures two major socio-cultural events, the 2008 presidential election day and the Thanksgiving day. For the Opinion Finder, you can see significant but short-lived spikes in the positive sentiment for those days. The GPOM series presents a more differentiated mood response. For example, in the calm series, you can see anxiety build up prior to the election day, represented by a bump in the calmness score. On the Thanksgiving day, you can see the happiness time series that spikes for that particular day. So we've obtained the mood series from tweets, which are the features, and also seen how they correlate with socio-cultural events, which is not that surprising. Now we want to study the relationship of these sentiment indicators with the movements in Dow. So the authors performed the Granger causality analysis, which basically states that if a variable x causes y, then the changes in x will occur before changes in y. So they try to formulate the changes in the Dow values as a linear function with past changes in the Dow and past n days of the mood time series. They do this separately for all the GPOMs and Opinion Finder mood series. The observations are that calm series has the highest Granger causality values with the Dow for lags ranging from 2 to 6 days. Other mood series from GPOMs and Opinion Finder do not correlate that well. The time series shown below shows the Dow values time overlapped with the calm series, and you can see the correlation between them, including the direction of movement. October 13th is an interesting case where the two series diverge significantly, which may be due to the Fed's decision of a major bailout on the same day. This shows that the mood series from public data might not capture some news which affects Dow significantly. The Granger analysis looks at linear relationship. However, the stock market intuitively should follow non-linear relationship between the mood series and the Dow. So they analyze this non-linearity using a self-organizing fuzzy neural network. Quick summary of a SOFNN. It's basically a generalization of the neural network architecture to handle fuzzy logic systems. The network has almost same architecture as a typical neural network, but usually has Gaussian activations. The self-organizing is a special type which provides an efficient way to learn the structure of the network. These networks are usually 4 to 5 layers deep. Results from the nonlinear analysis. The mean absolute percentage error is lowest using a combination of calm and happy signals. Thus, happy itself was not that useful as mentioned in the linear analysis, but it turns out to be useful in combination with the calm signal when considering nonlinearity. The calm signal itself leads to best prediction of the direction of Dow's movement, that is up or down. Other signals are not very useful, with some combinations actually hurting the accuracy. Though it's a well written and quite highly cited paper, I'll mention some limitations of the current paper. So, around 2008, when the analysis is done, most users and especially the active ones are expected to be from the US, but DAO is known to be affected by people worldwide. This is not factored explicitly into the model. The sentiment of tweets might not be reflective of the actual sentiment of the people, thus, the conclusions drawn might be somewhat false. Also, this was performed during the height of the financial crisis, and hence there might be some bias to people using Twitter more for expressing their concern, anger.
Our related work have covered three main areas: how Twitter data is used for financial prediction. The second is about how Twitter data is used for other prediction tasks. And finally, we'll talk about how other data are used for financial predictions. The first area we're going to present is about how Twitter data is used for financial predictions, which is Boland's paper it's mainly about. The first paper is closely related to Boland's work we just discussed. The techniques in the dataset used in this paper are built directly on the one used by Boland, so that we can have a direct comparison between these two papers. Similar to Boland, in this paper, the authors built a 5-layer self-organizing fuzzy neural network. Their results are in some conjunctions with Boland's, but there are some major differences as well. Specifically, the results show a better correlation between the calm and happy mood dimensions with the Dow Jones Index average values, unlike Boland's results, which show high correlation with only the calm mood dimension. The other difference is the cross-validation method. The traditional K-fold cross-validation method is not applicable to this type of time series problems. So in this paper, they apply a novel validation technique, which they name it the K-fold sequential cross-validation. Simply speaking, it trains the model using all data up to a specific day, and then tests the prediction for the next K days. The sequential cross-validation accuracy for the fuzzy neural network using the calm and happiness features reaches around 75% accuracy. Recall that in Boland's paper, the accuracy was 87%. Although Boland's paper has proven that statistically, the probability of this happening with random success is pretty low, Boland's method yet only used a small set of the data. While in this paper, with the K-fold sequential cross-validation technique, they have cross-validated over the entire period, which in this case might be a better indicator of the performance of the model. Finally, since the model can be able to predict the Dow Jones Index average closing value one day in advance, they construct a naive, greedy strategy for portfolio management to test out their data. They maintain a running average and the standard deviation of the actual stock value, buy in if the predicted price for the next day is less than a certain threshold of the standard deviation from the mean, and sell it if the predicted value is higher than the certain threshold than the actual value when they buy in. By simply following this strategy, they are able to obtain 530 Dow points worth of profits within 40 days. From this standpoint, we can see that the model does have some prediction power of the future stock price, but of course, this is far from being conclusive.
Here is another paper that used tweets to predict stock prices. It was written by So et al. In 2014. One of the objectives of this research was to solve some of the unanswered questions in Boland's paper. First, instead of predicting stock index, this paper was trying to find the correlation between tweets and average daily stock market returns of firms in the S&P 500. Second, in Boland's paper, only one emotion, which is calm, was proved to be strongly correlated with stock index, and they couldn't explain the delay of influences of calm mood on stock index. To give a better understanding of how emotions are correlated with stock returns, this paper adopted another method to conceptualize emotions. They classified each term in tweets about a single company into positive, negative, and neutral using Harvard's Ford Dictionary, and developed 3 formulas to calculate the emotional scores, which only employ the number of occurrences of positive words and negative words. This score, together with other covariates including past returns, cumulative normal returns, would then fit into a linear regression model, same as Bolen's one. Their experiments were divided into two parts. The first part was to find the correlation between emotional scores of tweets and firms' same-day return, next return, and 10-day return, while the second part was to test whether tweets from users having more followers will cause a greater impact on firms' stock market performance, since information in their tweets tend to disseminate faster. They achieved this by giving different weights to the cumulative emotional scores for users having more followers. Two major findings were concluded in this paper. First, results showed that emotions of tweets have more predictive power for same-day and 10-day returns, but less for next-day returns. Particularly, tweets from users having more followers tend to have a greater impact on the same-day return, while those from users having fewer followers have more influences on 10-day return. There are also some limitations in this paper. The sentiment analysis method in this paper was to classify words into three categories, and they simply added up their occurrences and fit the numbers into their formula to represent the emotions of tweets, but they failed to explain the intuition behind their formula. In addition, they didn't provide a meaningful explanation why emotional scores only correlated with same-day and 10-day returns, but not next-day returns. Last but not least, similar to Bolen's paper, it cannot guarantee causality between tweets and firms' stock returns. The next paper that uses Twitter data to predict stock was written last year by Huang et al. They also use 6 dimensions to represent emotions of tweets called poems. These 6 dimensions are actually very close to the ones used in Bolen's paper. But instead of using fuzzy neural networks, they implement 2 other neural network algorithms with 2 different purposes. A deep neural network was developed to select predictive Twitter moods because of its good fitting capability, while they utilize convolutional neural networks to explore temporal patterns of financial data and Twitter moods through convolution and pooling. Prior to their experiments, 50 million Twitter data from 2010 to 2011 were collected. These data were further processed to extract moods and used together with financial growth rates to train the 2 neural network models and make predictions. The result is either up or down, representing the trend of next-day stock index. One of the key findings is that combination of multiple moods provides more predictive power than single mood. Here we'd like to share some of our thoughts about the papers we've talked about and read, since they are all highly related. First, 3 of the papers above mentioned showed that the calm dimension have strong predictive power, but all of them can provide in-depth analysis behind this. Also, they draw different conclusions about the best feature combination, which means there's currently no conclusive answer to how sentiment correlates with stock prices. A similarity we found is that results from these papers have shown that usually a delay of few days is seen in the correlation between tweets and index movements. And also, some widely used sentiment analysis techniques in existing researches, including GPOMs, POMs, word classification, and the classification algorithm includes neural networks, support vector machine, and etc.
Next, we'll talk about how Twitter is used in other areas. Twitter has also been widely used to measure public opinion. This paper describes a system for real-time analysis of public sentiment toward presidential candidates in the 2012 US election using Twitter data. This paper used Amazon Mechanical Turk to do the sentiment annotation on in-domain political data, which generates around 17,000 annotated tweets. Using these tweets as training data, they built a naive Bayes model on unigram feature. And with this model, they further constructed a system that keeps track of the volume, sentiment, and trending words during the presidential election run. Here's a small demo of the system. The top left chart bar shows the number of positive and negative tweets about each candidate, classifying them based on naive Bayes model. The right shows the tweet volumes and the trending words computing using the TF-IDF score. One important finding they have about using this system is that the tweet volume is largely driven by campaign events, such as the President's State of Union address, televised primary debates, or the moment when the primary election results were released. This system is just a simple example of how Twitter can be used as a measurement of public opinion. There have been lots of other ongoing work studying public sentiment during the presidential election, or even try to predict the election outcome using public sentiment data.
For the last part, we will introduce a related work that uses other data sources on financial predictions. For this paper, they used the data on Wikipedia to see whether changes of the usage pattern could be used to predict stock market move. Here, they define usage patterns as the viewing or editing on Wikipedia pages in order to compare movements between usage patterns and subsequent stock market movements. This paper implemented a hypothetical investment strategy that trades Wikipedia page views and edits on the Dow Jones Industrial Average. The hypothetical investment strategy is as follows. Assume in a week, if the number of views or edits have increased, we sell the DJIA at a closing price at the first trading day. And then we buy the DJIA at a closing price on the first trading day next week, opposite if the views or edits have decreased. The cumulative return values is defined as follows. As a result, we could see on the left in this figure the return distribution based on the Wikipedia views and edits toward DJIA companies has higher return values for view-based strategy than the return values of the random strategy. Here, the random strategy means that there is both a probability of 0.5 of selling or buying DJIA each week. Seen on the left bottom of the page, the figure also suggests that there is a significant difference between the return values generated by the random strategy based on Wikipedia articles on other financial topics. However, here, there are no such relationships for articles on non-financial fields. In conclusion, the paper suggests that before stock market falls, there will be an increase in the number of page views of articles relating to companies or other financial topics, proving new insights for collective decision making. The following is our conclusion and comparison between our paper and the related works. First, for our paper, the experiment shows that calm sentiment correlates with future DJIA movements. Then, in the related work on exploiting Twitter moves to boost financial trend prediction, it shows that taking multiple moves into consideration could provide better predictions. Last, for the last two papers, it shows that Twitter can also be a good data source to measure public sentiment, and that also other data sources such as Wikipedia could also be used to predict stock market movements. So the above is our presentation for our paper, and we look forward to your feedbacks and questions. Thank you.